In this video, I will show you how to graph logarithmic functions when there is a horizontal compression, which makes it a little bit more tricky than normal. So first things first, I'm only going to graph the parent function to start off with. So I'm going to treat y equals natural log of 2x as the parent function, which does include the horizontal compression in it. But what I'm not going to do is the plus 7 and the minus 1. I will do that on the graph itself. All right, so what we're going to do is we will start off with the y values. Anytime you're graphing a logarithmic function, I think the easiest thing to do is start off with the y values. And we will always use -2, -1, 0, 1, and 2. So we need to find the x values of the parent function. So ultimately I'm going to graph natural log of 2x. But before that, I really want to consider simply the natural log of x, even without the 2. I'll do the 2 in a moment. Understand that natural log has an invisible base e. All right? Natural log means log base e. That's important because if I want to find the x values, I need to rewrite this in exponent form. So you start with the base, which is e. I'm going to write that down. Now the x and the y are going to switch sides. So the x is going to end up over here, and the y is going to end up right here. So I'm going to use this equation in order to find the x's. Now, somewhere in the back of your mind, remember that e is approximately 2.72. In fact, I'm just going to use 2.7 as an approximation. So that means to find these x values, I'm doing so e to the y power. So I'm doing e to the -2 power, and e to the -1 power, and e to the 0 power, and e to the 1 power, and e to the 2nd power. Start from the bottom. E squared. Now I'm going to just use a 4-function calculator. And again, I'm approximating with 2.7. So let's do 2.7 squared. So that is 7.3. And then e to the 1 power would be the 2.7. Anything to the 0 power is 1. Now these last two will be the reciprocals of the bottom two. So 1 divided by 2.7 is 0.4. And 1 divided by 7.3 is 0.1, approximately. So these are my x values. So what I've graphed so far is just natural log x. But I want to go ahead and deal with this horizontal compression. And by the way, so if when you're doing the horizontal stuff inside the function, it's always the opposite of the way it looks. So numbers that are bigger than 1, like 2 and 3, they look like they would be stretches, but they will actually be compressions, like 1/2 and 1/3. Okay, so that's what's happening. So I'm going to need a new x column to reflect the horizontal compression that's about to happen. Okay, so I need a new x column. So what I will do is I will stretch this out to make a new x column. Okay, anything on the inside is affecting the x values, so that's how I know I need a new x column. Because it is a compression, I need to multiply all my x values by 1/2. Okay, so this column will be 1/2. In other words, I'm going to divide all of these by 2. Okay, so that means I'm going to have 0.05, 0.2, 0, comma, I'm sorry, 0.5, no comma. Let's see, 2.7 divided by 2 is approximately 1.4. And then 7.3 divided by 2 is approximately 3.7. Okay, so those are my new x values. So these points represent everything that I have highlighted here in yellow. Natural log of 2x. It's everything except for the plus 7 and the minus 1. So let's plot these points. Do not connect the dots because this is not your final answer. So 0.05 is really close to 0. So 0.05 comma negative 2 is going to basically look like it's on the line. 0.2 comma negative 1 is not much better. All right, 0.5 comma 0 would be right here. 1.4 comma 1 would be about here. And 3.7 comma 2 would be about here. Okay. Now, the next thing I'm going to do is actually pretty tricky, because at a glance you might think that this will be to the right 7, because everything in here is the opposite of the way it looks. So plus 7 would be to the right 7, sorry, to the left 7. But this is not really a 7, because in order to read this properly, you need to factor out the 2. All right, if there's a b value in there, you need to pull that outside of parentheses. So when I am looking at 2x plus 7, I need to factor out that 2. And so that's going to be x plus, and then this will be 7 divided by 2. So this will be 7 over 2, which I could just say 3.5. So this is really y equals natural log 2 times x plus 3.5, and then minus 1. Okay, so you have to factor out that 2 before you know what's going on. So now I can say the plus 3.5 means everything needs to be moved to the left 3.5. The minus 1 means everything needs to be moved down 1. So I'm going to take these 5 points and I will move them left 3.5 and down 1. All right, these red dots represent the final answer. But before I draw the curve, I need to show the new vertical asymptote. Because the graph has shifted left 3.5 from the parent function, the vertical asymptote is going to be here at x equals negative 3.5. So your graph should look something very much like this. Okay, the domain is going here from left to right. That's going to be negative 3.5 to infinity. The range, all right, that's the y values from bottom to top. That's negative infinity to positive infinity. And the asymptote is going to be not y equals, it's a vertical line, so I need to put x equals Negative 3.5. Or negative 7 over 2, either way. All right, let's do one more example. Now, we are going to start off by graphing the parent function, which is y equals log x. All right, that's truly the parent function. So that's where I will start my table of values. But then I will go ahead and include the 4. So what I will actually end up graphing is y equals log 4x. Okay, but of course, to get the final answer, I'm going to have to include the minus 12 and the 5. So when I get to that step, the main thing you have to watch out for is the fact that you have to factor out the 4. You can't leave it like this. This is not shifted right 12. You need to pull that 4 outside of parentheses. So this is really going to be x minus, and then 12 divided by 4, so x minus 3. Okay, and then the plus 5. So don't forget to rewrite the equation like this before you do your horizontal and vertical transformations. Okay, so I think I'm going to put my table of values over here this time. Okay, so here comes my table of values. Okay, start with the y values whenever you're doing logarithms. So the y values, I will always start with negative 2, negative 1, 0, 1, and 2. So for these x values, I am using this equation. Okay, but I need to rewrite this in exponent form so that I can get the x values. So if I rewrite this in exponent form, please understand that the base is 10. So start with the base of 10, and then the x and the y switch sides. So the x is going to end up over here, and the y will be here. So x is equal to 10 to the y power. So this is what I am going to use to get these x values. Okay, so I'm doing 10 squared, which is 100, 10 to the 1 power, which is 10, anything to the 0 power is 1, and then this will be 1/10 and 1/100th. Notice it's the reciprocal of these two at the bottom. All right, so that's the parent function. Now, before I graph anything, I'm going to go ahead and deal with the 4. A 4 inside the function like this is a horizontal compression by a factor of 1/4. So this is going to affect the x values. So I'm going to need a new x column. So I'm just going to extend this out. All right, and because it's a compression by a factor of 1/4, I'm going to do 1/4 of each of these. So this is going to be 1 over 400. And this is going to be 1/40th. Okay, and this is going to be 1/4. And then, let's see, 10 divided by 4 is 2.5. And of course, 100 divided by 4 is 25. This is 2.5. So this is my new x column. So that's what I'm going to use. So let's go ahead and plot these points, but just don't connect the dots because this is not the final answer. Of course, 1/400th is so small, it's going to appear to be on the line. So 1/400th comma -2 would be right here. 1/40th is also so small it's going to appear to be on the line. So 1/4 comma -1 is going to be here. 1/4 comma 0 is just beginning to come away from the line. And then 2.5 comma 1 is right there. 25 comma 2 is way off the graph, so we will have to suffice ourselves with these 4 dots. Okay, but do not connect them, because it's time to talk about the horizontal and vertical transformations. Okay, because of the -3, everything will shift to the right 3. Because of the +5, everything will shift up 5. Speaking of that right 3, that's going to change the vertical asymptote. So I will have a new vertical asymptote here at x equals +3. Alright, so there's my new vertical asymptote. Show it as a dotted line. Okay, so I'm going to move each of the 4 dots that I graphed right 3 and up 5. Okay, so right 3 and up 5 would be here. And then the next one will be here. And the next one will be here. And then the next one will be here. Okay, it really should be right in the middle. Okay, so those 4 dots show me where the final answer will lie. So I'm just going to draw this curve as best I can. Okay, this is really hard to do with an electronic pen. I'm using a bamboo tablet. So it's like I'm looking in one direction, but then I'm drawing somewhere else, so it's really weird. Okay, that wasn't too bad. So that's what the graph is going to look like for number 6. So now it's time to do the domain and range and state the asymptote. So the domain is going to be the x values, so that's from left to right. So that is from 3 to infinity. The range, that's the y values. It goes down forever and then up forever. So that's -infinity to +infinity. And then the asymptote is the vertical line x equals 3. So that is how you do problem number 6. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.